In this video, we're going to talk about exponents and exponent rules. So, an exponent tells us how many times to multiply a number. Okay, so in this example, we have the number 3 being multiplied 1, 2, 3, 4 times. So instead of writing 3 times 3 times 3 times 3, we can use exponents to represent what's going on. So we can write it as 3 to the power of 4. Because we're multiplying the number 3 4 times. So the 3 would be considered our base, and the 4 is our exponent. The base is the number that's being multiplied. The exponent is how many times we multiply that number. So as an example, if we have, say we have 3 to the 5th power, we can break that down or expand it as 3 times 3 times 3 times 3 times 3. Okay? Because it's telling us to multiply the number 3 5 times. If we have x times x times x, then in this example, our base would be x because that's the number that's being multiplied or the variable that's being multiplied. And we're multiplying it 1, 2, 3 times, so the exponent would be 3. So let's talk about some rules of exponents. So the first rule we're going to look at is called the product rule. Now, before I start, I want to point out that wherever you see an x, like let's use this as an example, 3 to the 4th power. The 3 would be the x, and m is the same as the 4. So it's just a variable placeholder. Okay, so right here where you see x to the m power, that's just some base raised to some exponent. All right, and then here you see x to the n power. What that means is they have the same base, but different exponents. We're using m to represent this exponent and n to represent this exponent. So, product rule. To multiply when two bases are the same, we're going to write the base and add the exponents. So we're going to write the base and add our exponents. So if you notice in our example, or the rule that writes it, that spells it out, x to the m power times x to the n power, meaning they have the same base, the exponents are just different. We're going to keep the base and just add the exponents. All right, and we have a few examples right here. So in this example, both terms have the base x. So if we're multiplying them, that's the operation that's in the middle, we're going to add the exponents. So keep the base and add the exponents. 3 plus 8 is 11. And that's multiplying our exponents, multiplying terms with the same base. We just add the exponents. Same here in this example. They both have a base of 2, so I'm going to keep the base and add their exponents. 4 plus 2 gives us 6. And in the third example, yes, I know that there's two variables or two bases, so we keep both bases. If there's more than two, you basically just keep whatever's there. So we have both x and y. So now we need to figure out the exponents. So you add x with x, so the 2 plus 3 gives us 5. And then this y has an exponent of 1. This y has an exponent of 4. So 1 plus 4 makes 5. So the answer for this one will be y to the 5th. I'm sorry, x to the 5th, y to the 5th. So product rule, you keep the base and add the exponents. Now for a quotient rule. The quotient rule is basically the opposite of product rule. To divide when two bases are the same, we're going to write the base and subtract the exponents. Subtract the exponents. So in this example, they both have the same base, so we will subtract their exponents. So it's the top minus the bottom number, or the top exponent minus the bottom exponent. So here, they both have the base x, so I'm going to keep the base. But then we have to subtract their exponents. So 5 minus 2 gives us 3. So x to the 5th power divided by x squared equals x to the 3rd power. Same here. They have the same base, so we're going to keep the base and subtract the exponents. 5 minus 3 leaves us with 2. So our answer is 3 squared. For the third example, just like before, even though we have more than one variable, we're still going to keep both bases, x and y, and subtract their exponents. X with x, y with y. So 4 minus 1 leaves us with 3. 6 minus 2 leaves us with 4. So our answer for this one is x cubed, y to the 4th power. The next rule we have is the zero exponent rule. This rule states that any base except 0 raised to the 0 power is equal to 1. So you see, any number, any base raised to the 0 power is equal to 1. And that is true for everything, no matter what number, what variable it is raised to the 0 power, it is equal to 1. So, like in this example, where we have y to the 0 power, it is equal to 1. 6 to the 0 power is equal to 1. And 7a cubed b to the negative first power, it's all in parentheses and the 0 is on the outside, so that means all of this is equivalent to 1. So the zero exponent rule, any number, any base raised to the 0 power is equal to 1. The next rule we're going to discuss is the power rule. To raise a power to another power, write the base and multiply the exponents. So to raise a power to another power, we're going to write the base and multiply the exponents. So if you notice here, we have our base, some number, raised to an exponent inside of parentheses, and we have another exponent on the outside. That's raising a power to another power. So what we're going to do is keep the base, but we're going to multiply the two powers. So in example A, our base is x. So we write our base, but then we're raising x cubed to the fourth power. So we have to multiply. 3 times 4 is 12. So this is x to the 12th power. Same thing in this example. Our base is 3 this time. So we keep our base and we multiply the exponents. 2 times 5 gives us 10. So this is 3 to the 10th power. And with our third example, our base is z. We have z to the 4th raised to the 11th power. So we're going to multiply 4 and 11 to get 44. So this is z to the 44th power. The next rule we're going to discuss is the expanded power rule, meaning the exponent goes to everything in the parentheses. So we have two examples here. Say we have two bases, some number x, some number y, and we raise it to the m power. We can then expand this by giving the exponent to each factor in the parentheses. Each one of these are called factors. Okay, so as a result, it'll be x raised to the m power times y raised to the m power. Same thing if it was a fraction. X divided by y raised to the m power. So the m goes to whatever is in the parentheses. So it'll be x to the m power divided by y to the m power. Okay, so let's put this with some numbers and so you can understand. The first example is 2a raised to the third power. So what that means is this is 2 to the third power times a to the third power. So we did expand it, but it's good practice if the base is a number, we go ahead and figure out what the go ahead and raise it to that power and get that number. So 2 to the third power is the same thing as 2 times 2 times 2. We're multiplying the base 2 3 times, which gives us 8. So the final answer for this one is 8a cubed. For B, we have 6x cubed squared, quantity squared. Okay, so the 6 gets the square, but then we also have to give the square to the x. But if you recognize this, this is the power rule. We just discussed this. So when we're raising a power to another power, we have to multiply to get the exponent. So this will be expanded. This is 6 squared x to the 6th power. But again, if the base is some number, then we need to go ahead and evaluate. So 6 squared, which is 6 times 6, is equivalent to 36 x to the 6th power. Okay, for C, it's the same with the fraction. Whatever is in there, we have an x squared divided by y. So we're going to apply or give the exponent to the x squared and to the y. Since it's already an x squared, this is power to a power, or the power rule. So you multiply their exponents. This would be x to the 8th power divided by y to the fourth power, because we just go ahead and give it to the y. Which, I mean, the exponent of the y is 1 anyway, so 4 times 1 is 4. And then for the last example, all right, this one's kind of involved. So we would still give the exponent to everything that's inside the parentheses. This is 2x divided by 3y squared, quantity cubed. So this will be 2 to the third power x cubed over 3 to the third power y to the 6. And then we just take that extra step to evaluate our numbers, the ones that have numbers for the base. So 2 cubed is 8, x cubed. 3 cubed is 27, y to the 6. Now we would go ahead and see if we can simplify this fraction, but 8 over 27 is going to stay. So that is expanded power rule. Basically, give your exponent to everything in the parentheses. We have one last rule to talk about. And this one can get a little confusing, so I'm going to try and explain this as best as I can. So negative exponents. Negative exponents, they don't mean the same thing as a regular negative number, okay? It basically just means that the base is in the wrong spot, okay? Either it needs to move up in the fraction or move down in the fraction. Meaning, if a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. So if it starts off as a negative exponent, all right, this is technically in the numerator because it's over 1. So it means that base doesn't really belong in the numerator. It should be down in the denominator. All right, and now you see that the exponent is positive, and a 1 is in its place at the top. And the reverse is true. If you have that negative exponent in the denominator, it means it belongs in the numerator, so it needs to move up. And here we have x to the m power. The m is positive, or the exponent is positive, and it's in its correct spot. And if you have a fraction that the whole thing is raised to a negative exponent, both of them are in the wrong spot. So you flip the fraction to make the exponent positive. If you notice, it was x divided by y when the exponent was negative, but now it's y divided by x, and now the exponent is positive. We want positive exponents as much as possible, okay? So here are a few examples to practice with these exponents, or negative exponents. So if we have x to the negative third power, and this is in the numerator, what that means is this x as our base belongs in the denominator. So what I'm going to do is put a 1 at the top, and then we now put our x in the denominator. But instead of writing a negative 3, we're going to put a positive 3 because now the base is in its correct spot. Same thing in example B. We have 4 raised to the negative 2 power, or negative to the, negative 2 power. So this is technically in the numerator. So that means our base, the 4, really belongs in the denominator. So we're going to put a 1 at the top as a placeholder and move the 4 down. But instead of writing a negative 2, we're going to make our exponent positive because the 4 is now in its correct spot. Now example C, or the third example, you look at what base is the negative exponent attached to. This whole thing is over 1. To point out, the negative 4 has an exponent of a positive 1. So that one's in the correct spot. The x has an exponent of a positive 5. So that one is also in the correct spot. So negative 4 and x to the 5th power stays where they are. But the y has an exponent of negative 2. So that means the y base actually belongs in the denominator, and the exponent will now be positive. Example D applies to when it's a fraction and the whole thing is raised to a negative exponent. Okay, you have to flip the placement, flip the denominator and the numerator, and we also will have to raise the powers to the 3rd power. So our first step is to flip them. So this will be y divided by x squared. Now the 3 is positive because I put them in their correct spot. And now I can go ahead and give the 3 to each part of this fraction. So this will be y cubed over x to the 6th power, because 3 times 2 gives us 6. In this example, all right, there's a few things we need to take care of. There's multiplication going on for one thing. Multiply first. So we have 3 times negative 2. So we're starting off with the negative 6. Then we have negative 2x, or x raised to the negative 2 power in this parentheses, and x to the 1st power. Remember back to the first rule that we talked about in this video. When you're multiplying bases, you add their exponents. So we keep the x, but on the x is going to be negative 2 plus 1, which leaves us with a negative 1. Okay. And now we also need to take care of the y's. So I'm going to keep my y. And this y is raised to the 1st power. So this is technically y minus 3. And that leaves us with a negative 2. So now that we've multiplied these two terms, we can now go ahead and correct the exponents. Remember, all of this is currently in the numerator. So the negative 6 is good. The negative 6 can stay where it is because the exponent is a positive 1. But the x has an exponent of negative 1, which means the x belongs in the denominator. Same thing with our y. It has an exponent of negative 2. So y squared belongs in the denominator. Okay. We have 2 more examples. This one is set up as we can clearly see what is in the numerator and the denominator. So we just need to check for negative exponents to put them in their correct spot. If you look in the numerator, the a has an exponent of negative 2. So that means the a will have to move down. So set up our fraction. The a is going to start at the bottom and make our exponent positive. The b cubed, that's positive. So b is in the correct spot. C to the negative 4th power. Negative 4th power, which means it's in the wrong spot. So c needs to move up in the numerator. And then d is also raised to a negative exponent, so that means d also needs to move up. So we will end up with b cubed y to the fourth d divided by a squared. So in this last example, we're first going to give the exponent to everything in the parentheses, just like the power rule says. So this will be -2 raised to the -2 power. And then, so this is x. It's 2 times -2, which is -4. We have y to the -4th power, so I'm going to keep my y. And this is going to be -4 times a -2, which is a +8. So now that I have raised all of these to, the -2 power, we can now correct the negative exponents. Remember, this is all currently in the numerator. So the first thing I see is that -2 is raised to the -2 power. So it belongs in the denominator, so this would be -2 squared. The x also has a negative exponent, so that also belongs in the denominator. I'm going to make it positive. But the y has a positive exponent, so it stays in the numerator. And now the last thing I'm going to do to fix this is go ahead and evaluate what is 2 raised to the 2nd power. So we end up with the final answer of -y squared, to the 8th power divided by 4x to the 4th. And one thing I want to point out, I know the negative was down at the bottom with the 2, or even originally up here with the 2. Since it's not in parentheses, it's just a negative applied to the whole fraction, so I just brought it out to the front.